Here's some straight chord and tangent question, or chord and intersecting chords questions. So this first question is actually very much linked to the first fact, that a chord, the perpendicular bisector, will go through the middle. So this is an angle at right angles, it's going through the middle to a chord, so this x is the same, or what we've done is we've bisected that chord. So x is equal to 12 because we've bisected the chord. Question 2, same thing, we got the bisector of the chord, so that's a 9. These other lengths aren't needed in that one. Same thing going down through all of those. This one, it's a radius, so of course that one must be 13 as well. This one again, it's showing a radius, so you need an 11 for that one. Okay, these ones are a little bit different, but they're still related. So we've now got our sides. So we've got 14.3 and this side is now 14.3. And we want to find the distance of that chord from the centre point. Well, we've got a right angle triangle, so we can use Pythagoras. We don't need to write out the equation, we just have to be able to record the fact. So the hypotenuse is 16.8. So 16.8 squared plus the sum of the two legs squared must be equal. So I now grab my calculator, do a rearrangement. So x is 282.24, and we're subtracting the 14.3 squared, which is 204.49. So x is the square root of that answer. The square root of 77.75. So x is the square root of that, which is 8.81. Which in this are round to 8.8. So we've worked out the distance of the chord from the centre point. Similar sort of thing going on with this one. Again, we've been given the midpoint and the distance this time, so now we're doing Pythagoras to find the radius of the circle. So x squared is the hypotenuse, which is 6 squared plus 15 squared, because this is also a radius on that side. So x is the square root of 36 plus 225. It's 261. The square root of that is 16.2. So 16.15549, which is 16.2 centimetres. So that answer there. The others are similar types of questions. Now we're looking at another question where we've got two chords crossing. There's one and there's the other one. So we now know that this one's got 8.2 on both sides, and this length here is a total of 14.8. Now if you remember the formula, it's you split things to create these two similar triangles, and the scale factor is going to be x over 8.2 is equal to the 8.2 compared to the 14.8. So the smaller one is 8.2 for that side, and that is similar to that side, the 14.8. which means we get this crossover. The two parts of the chord are multiplied is equal to the crossing chord multiplied. So x is equal to 14.8 divided by 8.2 squared, which is 657.2. 40.8. Got that the wrong way up, haven't I? 67.24. Multiply those, divide by 14.8. Will give me this leg, which is 4.54. We can't go really more accurate than the question did, so 4.5 centimeters. Last one. So we've got to find out the missing length PQ and what we need to find from it. So we need this length PQ over here. Which is that length there. So we need to find out how can we do this one. Well, it's the distance from PX times QX. So that scale factor thing leads to, well, if I do the two triangle part, so if I change this into a triangle across here, and a triangle across here, the scale factor between the two triangles is the whole length, PX, is similar to the length XR, because these two angles are equal, and also the length the whole length of SX is the same factor as to QX. So they're the similar sides on the triangle. Rearrange it and you get PX times QX is equal to SX times XR. PX is 10 plus X. I want to multiply it by QX, which is 10, is equal to SX, which is 15, times XR, which is 9. So when we rearrange this, we get 10 plus X is equal to 135 divided by 10. So X must be 13.5 minus 10, which is 3.5 centimeters. Okay, so that's using the two things. Remember, when the point goes outside, the triangles are flipped around to be similar.